Okay, boys and girls, so today we're going to be going over lesson 2, which is exponential growth. So as I read the do now, it says, which of the following represents exponential growth? And I have to explain my answer. So I'm just going to start off by highlighting exponential growth because that's an important vocab word. And then I'm also going to highlight explain because I know I'm not done until I've explained how I got my final answer. All right, so if I look at each equation, anytime you see a of x, b of x, f of x, we know all of those are really y equal. So I'm just going to rewrite this as y equals 2 times 2 to the x. And then I'm going to do the same thing on equation b. Instead of writing b of x equals this whole thing, I'm just going to rewrite it as y equals 2 times 1/2 to the x power. All right, that way it's a little bit easier to look at, more familiar. So now if I type this function into the graphing calculator that we had shown you in the video from yesterday, the app is Calculator X. When you type it in and you graph it, it should look something like this. So I'm just gonna add that diagram to my lesson here. And then I'll go back and clear it out, and then I'm gonna type this function in, again, just to get an idea of what it looks like. And after you type it in, it should look something like this, all right? Whenever I'm dealing with like a curved type of graph, whether it's exponential or it's a quadratic, anything like that, I always think of like a roller coaster. So as I'm looking here, you get on a roller coaster, you read a book, you do a lot of things from left to right. So if I were to get on here at the left-hand side and I were to ride that graph, I can see that I'm going up, 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 and I'm increasing. So I know that this equation, because it's increasing, is showing me that this is going to be a growth. If I look at equation B, same thing. If I start at the left and I make my way to the right, I'm on the graph at the left. If I ride it, I'm going down, 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 down. So I know that would be decreasing. And if it's decreasing, this would actually be considered decay, which is another important vocab word, which we're actually going to get to in the next lesson, all right? So just hang tight with this one. Today, we're really just focusing on exponential growth. So because this equation in A is increasing, I know this is exponential growth. I'm going higher and higher and higher at a very fast rate. So now if I answer the question, which of the following shows exponential growth? It's going to be equation A. And then it says I have to explain. So I know it's equation A because of a really important vocab word. It's because the rate is greater than 1. And I'm going to show you what that means in a minute. For equation B, I know that this would have been not the answer because equation B has a rate that's less than 1. All right, when I'm talking about a rate, I'm talking about this number right here that's inside the parentheses. So that's where I have my rate on equation A and my rate on equation B. 2 is greater than 1, so I know my rate is greater than 1. That means it's growing, it's a growth. Here, I only have half. I don't have a whole, I don't have 0, I have half. So I'm less than 1. So since my rate here is less than 1, I know that would be a decay, it's decreasing. All right, that's just answering the do now. So if I jump underneath, today we're just going to focus on exponential growth. We'll do a different lesson on exponential decay another day. All right, so I'm just going to, again, highlight what's important as I'm reading. So for exponential growth, let me highlight this because that's the goal of the lesson. It's any quantity that's growing at a fixed percent would be exponential growth. So that's really the most important vocab words here that we have to look at. And then this is the formula that you would use for exponential growth. So as I can see, y equals a times 1 plus r to the t power. So I have 3 different variables that I need to plug in for. Here's what all 3 of those guys are going to represent. So I know that A is the initial amount. Initial is a vocab word we went over yesterday. It means the amount that you're starting with, or it's the amount that you're beginning with. If I look at R, this is super important. So R is the percent written as a decimal. So we went over this for a while towards the end of yesterday's lesson. So I'm just going to give you two different examples on how you could change a percent to a decimal just to refresh your memory. So if I had the number, let's do like 9%. I know that every percent is out of 100%, right? So this is showing division because I have a fraction set up. So if I just do 9 divided by 100, the calculator is going to tell me it's 0.09. So I know that 9% is really 0.09. This is one method you could use to set up your percent as a decimal. Something different would be, okay, just like yesterday, we had wrote 9 by itself because we dropped the percent symbol. So I'm just going to take the number 9 and add a decimal. We had shown you that it goes in the back. And I know that every percent, again, is out of 100. And since 100 has 2 zeros, I'm actually going to move this decimal 2 places to the left. So 1, 2. Now it's over here. And anywhere you have an open space gets a 0. So again, I'm still getting 0.09 as an answer. So these are two different methods you can use to change your percent to a decimal. I would stick with one method that's going to work for you every single time. And then if I go back, now that I'm done going over R, T is just the time, which is pretty straightforward. It could be in months, minutes, years, depends on what the question gives you. All right, so now let's start going over this. So as I'm reading example 1, again, I'm just highlighting or underlining or circling all the important things. So it says Cassandra bought an antique dresser for $500. This is an important vocab word. If I'm buying something, it's, I'm spending money, it's money that's going in. So I'm going to keep that in mind. I'm buying a dresser for $500. That's a dollar amount, so I'm going to circle it. The value is a nice word. So the value, how much the dresser is worth, is increasing. So we know that increasing means to go up. It's increasing 6% annually. This is also pretty important. I know that annually means every year. And then it's telling me to write an equation. I'm going to underline this. I always like to underline the actual question so I know when I'm done I can reread it and make sure I answered the question completely. So I have to write an equation that's going to represent the final amount using y after t years. So I have to write an equation. Well, I know this is the equation that I'm going to use because as I read this problem, I see that the dresser is increasing 6%. So anytime you see increasing with a percent, I know it's an exponential growth problem. So I'm going to write y equals a times 1 plus r to the t. And then on the side, I'm going to set myself up here for success. So I know I have to figure out what a, r, and t will be. So as I look back up here, a is the initial amount. It's where I'm starting. So she bought the dresser for $500. So that's how much money the dresser was worth when she first bought it, where she started it. So that would be 500 for a. R is going to be my percent written as a decimal. So I'm going to take that 6%. And again, I know every percent is out of 100. So when I divide these, I get 0.06. So that's really going to be my R value for this equation. And then if I look at T, I know that T is time. So again, I can see that it's increasing annually. So that means every year. So how many years is this going on for? I don't know. It just says T years. It doesn't say after 5 years, after 10 years. It says after T. So I know that the time is literally just going to be T. Now I'm going to go back in and plug all those values for my equation. So I know A is 500. I know that R is 0.06. And I know that T is actually just going to be T because there's no time. It doesn't say how many years. And I'm going to call it a day because the question says write an equation, and that's what I did. It doesn't say solve. It says write an equation, so I'm done. All right, next page. If I look at example 2, I'm going to do the same thing as I'm reading. I'm going to highlight what's important and go from there. So it says Dylan is investing $600 in a savings account. I'm actually going to stop right there because there's a lot of important keywords. So if you're investing money, that means that you're saving money. So I'm just going to write that down. So I know that he's trying to, again, invest $600 in a savings account. So again, this is just further showing me that if I'm investing money, it's because I'm saving it. So he's going to start with $600 and he's going to save that money at a rate of 1.6% annually. And we already went over on the first page, annually means every year. We can even add that on, every year. All right. It's saying here that he doesn't make any deposits or withdrawals. So if I'm depositing money, that means I'm putting money in. If I'm withdrawing it, it's because I'm taking it out. He's not doing either of those things. So he's taking $600, putting it in the bank and just leaving it there for, it looks like 2 years. So I'm also going to circle 2 years because that's important. It says the interest was compounded annually. Good to know. Again, annually. So every year this is happening. And then the question says find to the nearest cent the balance after 2 years. So I want to know in 2 years, how much money will he have at that point? So again, I'm going to use the formula y equals a times 1 plus r to the t, because this is an exponential growth formula. I have a percent, and I know that percent is increasing because I'm saving my money. Because these go hand in hand, that's what's making this an exponential growth problem, which means I have to use this formula to solve it. So now on the side, I'm going to kind of speed things up here. I'm going to figure out what A, R, and T will be so I can plug in and solve. A will be 600 because that's where I'm starting. It's the amount of money that I'm first putting in the bank. R is going to be that 1.6% as a decimal. So when I divide, I get 0.016. And T, it says this is happening annually, so that's every year for 2 years. So T is 2. Now I'm good to go. Just got to plug in and solve. So we got y equals 600 times 1 plus 0.016 to the 2. I'm just replacing the variables. And then from here, I can type this whole thing into my calculator at one time. So if you go on that Calculator X app, if you were able to download it, you can type this all in at one time. So when you type it in, you get y equals 619.3536. But these are all real life. I have to reread the question. So it says find to the nearest cent. Cent is money, and I know that all money ends 2 places after the decimal. So I either have to round the 5 up or keep it. Based on that 3, his neighbor, he's going to stay. Because if this is 5 or above, he gets a shove. This is not 5 or above, so it stays. All right, so my final answer will be $619 and just 35 cents. I'm not going to go anywhere else with that. All right, example 3. Again, I'm going to read and just highlight what's important here. So it says a flu outbreak hits your school on Monday with an initial number. I'm going to highlight that initial number. So initial is where I'm starting. So that's my starting value. Initial number of 20 students that were ill, and they're all coming to school. It says the number of ill students is increasing. I'm going to highlight increases. And it says it's increasing 25% per hour. How many students will be ill after 6 hours? So the question says how many students will be ill after 6 hours? All right. I know that usually when we see the word per, we want to box that or highlight that in some way because per tells me to multiply. So I might as well box it for now just to keep us in that habit. Again, I see increases with a percent. So I know that this would be exponential growth. I'm exponentially percent growing, increasing. So I'm going to use y equals a times 1 plus r to the t. That same formula again. And on the side, I'm going to just set myself up for what all my values will be. So A is the initial amount. They're literally telling me that I'm starting with 20 ill students. 20 is where I start. R is the percent as a decimal. So I'm going to take 25%, put it out of 100%, and when I divide, I get 0.25. So that's going to be my rate as a decimal. And then T, it says that it's increasing per hour. So every hour, this is going to go up. So I want to know what's going to happen after not every hour, but after 6 hours. That was important. So I know 6 will be my time. And then I go back and plug in. So I have 20 times 1 plus 0.25 to the 6. And then again, I can just type this whole thing in to my calculator at one time. So you could just do 20 parenthesis 1 plus 0.25, close the parenthesis to the 6 and press enter. So on your screen, it should say y equals 76.293 ... There's going to be a ton more numbers, but I'm just going to reread the question. It says how many students? You can't have 0.2 or 0.3 or 0.5 of a student. You either have a whole person or you don't. So because I can't have just part of a person, I have to just stick with the number 76. So the final answer to number 3, how many students will be sick? 76. 76 students. All right. And now we're going to jump down to example 4. So it says a species of fly doubles. So I'm going to just highlight doubles. I know we've seen that in class before. It's doubling every month. So I'm going to highlight that as well. Every single month this is happening during the summer. If there are 120 flies, I'm going to circle it. That's important. 120 flies at the beginning of the summer. So I know that's my starting value. At the beginning of the summer, there's 120. How many flies will there be after 3 months? All right. I don't know if you guys are seeing this, but all the other problems we've worked on so far had percents. Example 2, example 3. If you look at example 1 on the first page, there was 6%. I don't see any percents here. I don't know if you do, but I don't. So now I'm like, oh my gosh, what am I going to do? Because I know that R is supposed to be my percent written as a decimal, and there is no percent. Don't worry, guys. We got you. You're just going to use a different formula instead. So anytime there is a percent, you're going to follow all these steps that I've been going over with you. If you have a word problem where I'm seeing that, again, doubles, if a species of fly is doubling, that means when you hear the word doubles, you should think the number 2. It's to multiply by 2. So I'm going to just write that down here. It's to multiply by 2. So I know that this is going to go up. This is increasing. Even though I don't see the word increases, I know that the word doubles tells me that that number will be going up. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, right? My numbers are getting larger. They're getting bigger. So I know again that I am increasing in some way. So this will be growth. And it still is going to be exponential growth, even though I don't see a percent. I'm seeing this keyword doubles instead. So just keep that in mind. This would still be an exponential growth question, only instead of using this formula, I'm going to use y equals ab to the x instead. So it still follows the same steps. I still have to plug in my a, my b, and my x. A is still the initial amount, which is the number you start with. So here I'm starting with 120. There was 120 flies at the beginning of the summer. So A is 120. X, that last variable, the last one that I plug in for, it's still the time. It's just instead of using T, for some reason they use X, but it's still time. Time is after 3 months. It says this is happening every month. So what happens after 3 months? So I'm going to use the number 3. This is the only part that's different. Usually we would have to do some work here to get that decimal, but there is no decimal. There's not even a percent. So I'm just going to write the word doubles as being the number 2. And now I'm good to go. I just plug in and solve. So I have y equals A, which is 120, times B, which is 2, to the x, which is 3. That's it. Type this whole thing into the calculator at one time, and it should be a perfect number, 960. So how many flies will there be after 3 months? 960 flies. All right. If I look at example 5, same thing. Just by doing a quick skim, I can see that there's no percent. So I got to read those for those keywords that tell me that this is exponential growth, but I'm sure we'll find them. So a population of 100 cells, I'm going to circle 100, that's important, is tripling every hour. When you see the word triples, I'm hoping that we'll all know this from when we went over trinomials. Trinomials have 3 terms. So if I'm tripling, it's because I'm multiplying, you guessed it, by 3. And then the question says to find the total number of cells after 4 hours. So on the side, I'm just going to write my formula, AB to the x. I know that it's getting bigger because when I multiply by 3, my numbers get larger. So that's my growth. And it's exponential growth because, again, that word triples is here. Triples means it's not going to be linear. It's going to be multiplying, which is exponential. All right, on the side, I'm going to write A, B, and X. I'm still going to plug in for my initial value, the time, and now it's just instead of the rate as a percent, it's just the rate as a number. So I know that my rate here, if I'm tripling, it's because I'm multiplying by 3. I know that my initial value, that first one I'm going to plug in for, would be 100, because that's how many cells I'm starting out with. And if they're tripling every hour, well, now I want to know not for every hour, but just after 4 hours. So that would be another important number that I should circle here. So after 4 hours, what would my answer be? So I'm just going to plug in my values. A is 100, B is 3, and X is 4. And I'm just going to type this whole thing into my calculator at one time, and you get 8,100. 8,100. So it says, what's the total number of cells? 8,100 cells. Underneath, we have some word problems to look at. It says that we have the function v of t. Here it is. It's representing the value v of t in dollars of a comic book t years after its purchase. The yearly rate of the appreciation is. So the question is asking me what the yearly rate is. I'm just going to underline that because it's important. I'm going to go back and just highlight rate because, again, that's the goal of the question. It's the vocab word I need to use, or the vocab word I really need to find. And then on the top, I'm just going to write that I know this formula is really the one that we've been using the whole time on the first few questions. So instead of writing v of t, I'm going to write y equals a parenthesis 1 plus r to the t. Again, it doesn't say to the x, it says to the t. So I know this would be like numbers 1, 2, and 3. I know that the rate is the value of r. When you first plug in, 1 and the rate are separate. I can see underneath here, they've been put together. So I must have added 1 to the decimal, which is not good because now I have to break them back up. So really, I know that 1 plus the rate plus that decimal is going to be that 1.017. all right? I need to find the rate. That means I want to get R by itself. So if I drop my train tracks here and I want to get R alone, that means I have to move the 1 over. So if I subtract 1 on both sides, these cancel out, and I know that R is just going to be 0.017. Now, if I look back at all of my choices, this is where it becomes really tricky because they're giving you all of the choices in percent form. Right now, you're in decimal form. So a lot of you, especially on tests and quizzes in the regions, this is where they try to get you. You're going to solve and do all this work correctly, and you're going to see 0.017 and think that's the answer, and it's actually not, because this is the decimal form. I have to change it to a percent. So it can't be 3 or 4 just because this is the number from the problem, which I'm not keeping, and this is not the percent. That's the decimal. So it's not 3 or 4. It has to be 1 or 2. So now instead of dividing by 100 like I've been showing you, I want to multiply by 100. Because earlier we had the percent and I wanted to change it to a decimal. So we divided by 100. Now I have the decimal. I want to change it to a percent. I'm going to do the opposite and multiply by 100. And you would have got 1.7, which should have been choice 2 as your final answer for number 5. That's just one way to get this answer. Another way is taking all of these percents and just making them the decimal. So again, I know that all percents are out of 100. So if I take 1.7% and put it out of 100% and divide, you get 0.017. And I can see that my decimals match, and I'm still showing you that 2 is the answer. All right, example 6. It says the equation A equals, here we go, is being used to calculate the amount of money in a savings account. That's important. I know savings means I want to increase my money. It says, what does the 1.02 represent? Okay, so again here, I know that this formula, A equals 1,300 times 1.02 to the 7. Because it's a savings account, I know that this must be exponential growth, which is really going to be that formula, y equals A times 1 plus R to the t. So they're asking me what the 1.02 represents. So I know that this number here goes with the 1 plus R underneath. I know that it couldn't have been a decay, so I'm going to cross out choices 1 and 3, because if it was a decay, this number inside the parentheses would have been less than 1. So for example, if you think of money, this would be $1.02. So I have more than 1. If it's decay, it would have to be less than 1. Like in parentheses, if it was decay, it would have to say something like 0.78, maybe 78 cents. That's less than $1. It would have to say again something like 0.52. It would have to be less than 1, okay? So over here, I know it has to be choices 2 or 4. Again, I'm going to just set myself up here with a little equation. I know that 1 plus R, when I add these together, is going to equal that 1.02. If I draw my train tracks, I'm solving for R. If I subtract 1 on both sides, just like we did before, I get R equals 0.02. But again, this is as a decimal. These are in percent form. So 0.02 as a decimal is not the same thing as 0.02%. So it would have to be choice 4. And again, I can always double check it because every percent is out of 100. So if I divide 2 and 100, I get 0.02. And now I can see here that my decimals are matching. All right, make sure you guys work on the homework. Feel free to pause the video at any time and try to just do your best to follow along.